Hello and welcome to another of my chemistry videos. Today we're going to talk about scientific notation, which is something that you already should have a pretty firm grasp on coming into this chemistry course, but we'll review it nonetheless. The Nevada State Science Content Standard that eventually applies to this will lead toward students know that in chemical reactions, elements combine in predictable ratios and the number of atoms in each element do not change. And our objective, upon completion of this lesson, students will be able to convert from numbers in standard form to scientific notation and back again. Okay, scientific notation. A number that's written in scientific notation has only one non-zero digit, in this case it's the 4, that's in front of the decimal place. And the base 10, so it'll be times base 10 with an exponent, is used to account for having moved the decimal. It's sort of like an abbreviation. If you get a big word, you abbreviate it shorter. It makes it a little bit easier to write, less time, less space. The exponent tells how many places to move the decimal and in what direction. For example, we could have something like, oh, let's say we've got 7, 5, 8, 0, 0, 0. Oh, we'll give it a bunch of zeros. Doesn't really matter at this point. Okay, you don't necessarily want to write all these zeros every single time. So your decimal, which would start here, is going to get moved up 1, 2, 3, 4, 5, 6, 7 places, and you're going to put it right here. So I'll rewrite it below. So we'll have 7.58, and the whole goal of scientific notation is to not have to write all those zeros. So I'm going to write times, got our base of 10 to the however many places we moved our decimal, and again that's 1, 2, 3, 4, 5, 6, 7 places. And there it is in scientific notation. And you could do the same thing if you have a really small number. Put that in over here. Got a whole bunch of zeros in front. Oh, that's good enough. We'll do the same 758. Okay, but this number is smaller than 1, isn't it? So when we move our decimal, we're going to move it to the right until we have a non-zero number in front of the decimal. Again, that's going to be a 7.58, just like we had in the last one we did, but it'll be times 10 raised to the, okay, so this number was smaller than 1, so it's going to be a negative exponent. That shows us that it's, our exponent's going to go to the right. And we got 3, 6, 7 places. So that negative sign can be pretty important. Huge difference between this number here and this one here. But just the same, helps you abbreviate them a little bit, gets rid of all those zeros, makes it easier to work with. In chemistry, we'll deal with some constants that may have an exponent of 23 or negative 34, or we deal with some really big and really small numbers in chemistry. And calculators don't necessarily show enough digit places to deal with numbers like this unless they're in scientific notation. Okay, so you should already know how to convert these. Like I said, I know this is going to be just review. So this first one here, have a number smaller, so we're going to move the decimal 1, 2 places to put it right behind the 7. So you should have 7.882 times 10 to the, you moved it 2 places to the right, so it's negative. And there's your answer. And this next one, we need our decimal. It starts right here. We need it to have only one non-zero number in front of the decimal, so it's going to go right to here. You'll have 1.18 times 10 to the 5th, because we moved it 5 places. 3, 4, 5, and it's a positive exponent because we moved our decimal to the left, and this number is bigger than 1. Okay, now here we're going to go the other way. Write each number in standard format. It's in scientific notation. We have a negative exponent, which tells us this number is going to be really small. We move that decimal 7 places, making this get smaller. We'll end up with 6 zeros out front, the decimal, 6 zeros out front, and then your 3443. This here is a larger number. You can tell it has a positive exponent. We're going to move our decimal 6 places from where it's currently at to make the number bigger. So 1525, and then 3 more zeros gives us 6 decimal places. Simple enough? Okay. Well, let's see what can we do with these and what will we do with these in this class. We can use them for multiplying very large numbers. And this, I'm certain, is review as well, but just in case, let's look at this. You know that when you multiply numbers together, you can rearrange them in any order you want. So I could first multiply this 2 right here with this 3 right here because they're just regular numbers. Okay, 2 times 3, simple enough. We know that's 6. Now when we have exponents, bases that have, bases, base 10, any numbers that have the same base and have exponents, when you multiply them, you can just add, multiplying, you add the exponents together. So we've got 10 to the 4th, 10 to the 5th, gives us 10 to the 9th. Okay, we can do the same thing here with division. We can almost treat these as 2 division problems. 2 divided by 3 gives us 2/3, or in other words, we'll have 0.66. It keeps repeating. We're just going to go a couple decimal places because it's just the idea in this lesson is just for you to get the concept of what to do with scientific notation. We know that it repeats. Okay, now when we multiplied, we added the exponents together. When we're dividing, we're going to subtract the exponents. So we've got 10 to the 4th divided by 10 to the 5th. So 4 take away 5 gives us a -1. Now we're not done yet because this isn't in scientific notation, so we have to move our decimal over 1 this way. So 6.6, since we moved the decimal to the right, the exponent becomes smaller or more negative, and our answer ends up being right here. 6.6 times 10 to the -2. Okay, again, like I said, this should all be review for you. I'm sure it's coming back to you now. Okay, so when we multiply, again, feel free to stop the video if you need to. I don't think these require any further explanation, so what I'm going to do is just uncover these, and you can work through them, stop the video, work through them, and then go forward a little bit to see the answers. Okay, multiply those together, your regular numbers, and adding together your bases. Move your decimal if need be. Same thing here. 8 times 1 is about 8. And adding your exponents, 10 to the -6. Okay, here we have division. And again, we 1.94 divided by 2.5. And we subtract our exponents, -2 minus 6, -8, there we are, -9. And again, you can treat it as 2 separate ones. If when you're dividing, you're using a calculator and you can input this whole equation, make sure you use these parentheses or you will get an error in your answer. You'll have a wrong answer and end up losing points. So always use those parentheses when dividing and you use scientific notation. Here's your other answer. Okay, last one. Now, this one may look a little bit bigger. It's kind of like an elephant. You eat an elephant one bite at a time, right? So we can do this in steps. And again, I'm sure you've seen this in algebra classes. So to simplify this, we can first do our multiplying. We can multiply this times this. And real quickly, that ends up being, what, 3.5525, a little messy, hard to write with a mouse, times 10 to the 12 on the top, and then you do the bottom, same thing, you can multiply this times this, you end up with 8.946 times 10 to the 13th. Now again, when you're dividing, you're going to subtract the exponents. 10, 12 minus 13 is -1, and this you divide like regular numbers. Change it to scientific notation if needed, moving your decimal, so you have one non-zero number in front of the digit, in front of the decimal, excuse me, and here's your final answer. Okay, that was a quick down and dirty review for scientific notation, and I hope that helps you to remember it. You will use this a lot in chemistry, and I'll see you next video.